Up till now on this channel, we have discussed underwater tunnels and sea crossing bridges, but never quite as something as we're about to show you. Just the sheer scale of this engineering will blow your mind. It's the world's largest immersion tunnel connecting Denmark with Germany and stretching up to 18 kilometers. It'll be built across the Fehmarnbelt, a strait between the German island of Fehmarn and the Danish island of Lolland. It will not only connect Germany and Denmark, but will also serve as a connection for Scandinavian countries and the rest of Europe. It's designed as an alternative to the current ferry service from Rodby and Puttgarden, which carries millions of passengers every year. Where the crossing now takes 45 minutes by ferry, it'll take just 7 minutes by train and 10 minutes by car. If you look at the world map, you can see that Denmark and Germany are connected by land and share a border. So why do you need a tunnel? Well, it's because Denmark is a geographically complex country. It's a mix of 1,400 islands scattered across the Baltic Sea. Even Denmark's capital, Copenhagen, isn't located on its mainland, but rather one of the isolated islands, Zealand. This means that the fastest route to Germany or Central Europe is via the Fehmarn Strait. At present, the only means of transport could be a flight, ferry, or a train through the Danish mainland, which will then drop you to northern Germany. To avoid this 160-kilometer detour across the Danish mainland and make travel more comfortable and fast, a direct pathway needs to be created between the Danish islands and Germany. This is where the concept of the Immersion tunnel comes in. By making a more direct route, Europe would be just minutes away from Scandinavia and vice versa. But why did Germany and Denmark choose an immersion tunnel over conventional structures like a bridge or an underground tunnel? Is it worth disturbing the sea for human convenience? Stick with us to find out the answer. The Fehmarnbelt Tunnel is part of a Trans-European Transport Network, or TEN-T, which aims to streamline infrastructure and reduce the environmental impact of Europe's transport network. Under its flagship, Europe will oversee the construction of new roads, railways, inland waterways, airports, seaports, inland ports, and traffic management systems. The Fehmarn Tunnel will go a long way toward creating a more interconnected and efficient community. By now, people are desperate to find a solution to the transport bottleneck, and they're justified. Denmark is set to start taxing flights departing from Denmark to limit the effects of air pollution. This is due to the limited capacity of ferries, forcing people to commute via car or take a train. Currently, if you take the fastest train between Hamburg and Copenhagen, it'd take you around 4.5 hours. When the tunnel's completed, the same journey will take 2.5 hours. The traffic between the Scandinavian peninsula and Germany via Denmark can either take the ferry across Fehmarnbelt or take a longer route via bridges between the islands of Zealand, Funen, and the Jutland Peninsula. Discussion for the project can be traced back to the late 90s. At the time, both countries were eager to construct a sea crossing bridge rather than a tunnel. They envisioned a bridge with a 4-lane motorway and 2 electrified rail tracks. This solution was for years regarded as the most likely scheme, and detailed plans were drawn up. After a whole decade and several feasibility studies, the Danish project planner suggested that an immersed tunnel would instead present fewer construction risks and would cost about the same. So why was the bridge idea dumped away? The thing is that the seabed of the Fehmarnbelt was soft and hence unsuitable to support such a structure. An underwater sea tunnel was also rejected for the same reason. To construct a traditional tunnel, a tunnel boring machine is used that would dig the seabed. However, there was a risk of the seabed collapsing, burying all the valuable worth beneath the ocean. Not to mention that the cost of such an undersea tunnel would be outrageous. That's why an immersion tunnel was the only viable solution. An immersion tunnel means that parts of its structure will be built on land before being carried to its place in the ocean. In this way, it's a less invasive procedure rather than digging an underground tunnel. Valued at approximately $8 billion, the project will be financed by Denmark, which will collect a toll from the crossing. Germany will, however, pay 800 million euros to connect the crossing to its motorway network. European Investment Bank, EIB, provided a 123.5 million euro grant from the Connecting Europe Facility, CEF, for the project construction. The project has secured the money and the clearance from both the Danish and German governments. But how are they planning to build it? The first step in the process is the construction of a working harbor on the Rodby Haven in Lolland, Denmark, and the Puttgarden on the island of Fehmarn. New channels and access roads have been constructed, utility connections installed, and several existing buildings at the construction site have been demolished. New water holes and amphibian fences have also been established around the construction site. The working harbor at Rodby Haven will be the largest of the two, as this is where all the tunnel elements will be constructed. Factory halls will accommodate 6 production lines, 5 for the tunnel's standard elements and 1 for the special elements. A temporary village will be built for the 1,300 workers. The village was completed in the spring of 2023. The factory was completed in August 2023. The tunnel trench is being dredged by a fleet of special dredging vessels that'll dredge 19 million cubic meters of sandstone and soil. The dredged material will be deposited near the Rodby Haven, where it'll be used to create new beaches and recreational areas. The work harbor will receive the delivery of huge quantities of sand, gravel, steel, and cement, all necessary elements for tunnel construction. The factory at Rodby Haven will build 89 concrete elements, each weighing 73,000 tons. Together, their weight is equivalent to more than 13,000 elephants. The Fehmarnbelt tunnel will feature a 4-lane highway and a double-track railway. Each of the 89 tunnel elements will be 700 feet long, 137 feet wide, and 33 feet high. Each tunnel element will have 5 separate subtunnels, 2 for the cars, 2 for the trains, and 1 service tunnel in between. The tunnel elements will be placed on a 12-meter deep trench. The elements will be cast step by step in segments of approximately 80 feet in the factory. Each segment takes a total of 9 weeks to be completed. To ensure the quality of the casting process, the casting takes place inside climate-controlled halls. After all, it's an underwater project that's claimed to last 120 years in total. Each special element will include a basement area for technology. This will make the construction process and maintenance of the finished tunnel easier. Once an element's constructed, waterproof bulkheads are installed temporarily at both ends to keep a dry workspace inside. After that, it's taken to the dry port and towed into the place where it'll be lowered. The elements are then lowered to the seabed using cranes with high precision at the trench that was pre-dug by the dredging machines. At its highest depth, the tunnel will be 130 feet below sea level in the Baltic Sea. The bulkheads not only prevent water entry inside each element, but they also aid in connecting adjacent pieces. There's a sealed space between the bulkheads so that huge external pressure pushes them together when the water's pumped out. This ensures a completely waterproof and secure connection. Once all the elements are lowered through the cranes in their place, the work on the tunnel's technical and mechanical installations can commence. These include railway tracks, ventilation, cameras, communication systems, painting, and much more. Each of these systems will be thoroughly tested in the final part of the construction phase before the expected opening in mid-2029. To secure the tunnel, a layer of protective sand and gravel will be laid on both sides. With time, nature will transform it into a seabed, turning it into a haven for marine life. A tunnel portal is built in both Denmark near Rodby Haven and near Germany near Puttgarden to connect the tunnel's railway and motorway with the upgraded and newly built roads and railways. While both countries are adamant about completing the project by 2029, there has been some pushback from the local communities, especially from the German side. The concerns range from the potential increase of train noise to the loss of jobs related to the ferry business. Even though this project has also created hundreds and thousands of jobs, critics argue that they're only temporary and will end upon the tunnel's completion. Then there's the environmental aspect of it. The marine life in this area of the Baltic Sea thrives in clear water conditions, something the dredging of the seabed to create the trench for the tunnel will disturb. The project handlers at the Fehmarn AS push back by saying that their investigation has shown that there will be no harm to plant and animal life and the habitats of porpoises, birds, etc. In addition, as a result of this project, new natural areas and stone reefs on the Danish and German sides will be created. Nature needs space, and there will be more space for nature through the combined land and sea space. In theory, the Immersion tunnel is a fascinating feat in human engineering. As life in the sea continues undisturbed, beneath the seabed, there's another world dominated by humans and advanced technology. What are your thoughts on the Fehmarnbelt project? Will it beat other modes of transport like the ferry and air travel? Only time will tell. As the great writer Ernest Hemingway once remarked, there are only 2 places in the world where we can live happily, at home and in Paris. Paris, otherwise known as the City of Lights, is a heavily romanticized spot with major films and events occurring around the year within its confines. Every year, millions of people flock to this destination. A 2023 estimate showed 44 million tourists traveled to Paris, making it the most visited city. But beyond the Eiffel Tower, the Mona Lisa, the croissants, it's a city with real problems, and one of them is getting around. Île-de-France is a 12,012 square kilometer land that surrounds Paris and boasts a population of 12 million residents. A comparison among 6 different countries found that Paris is the most congested city on the continent, followed by London and then later on Ruhrgebiet in Germany. More than 8 million trips are made daily on Paris's transport network. Generally, Ile-de-France drivers spend more time in traffic compared to drivers in the UK, Germany, Belgium, Luxembourg, and the Netherlands. Paris traffic problems had their roots more than a century ago. In 1894, there were only 200 cars on the roads in France, then 3,000 in 1900, 10,000 in 1903, and 50,000 in 1910. The year 1920 oversaw an explosive increase in the number of vehicles by 150%, and by 1935 there were over 2 million vehicles on the road. The air quality deteriorated severely in 2015, with Paris recording the 9th highest death due to air pollution among major cities globally. There are two immediate problems with the Parisian transport system. One of them is that the system was built more than 100 years ago. This means that the dense mess of trains, trams, and buses laid out by Georges Eugene Haussmann in the late 19th century is no longer compatible now. As the population of Ile-de-France has tripled over the last century, space on land became limited, causing property prices to rise. This forced more and more people to relocate 30 to 40 kilometers outside the city and live in areas with fewer transport connections. That means that a large part of the population can't take advantage of bicycle sharing, car sharing, driverless trains, or electric buses. They also can't travel between suburbs easily because most train lines go straight into Paris. Missing a suburban train can mean waiting a half hour or more for the next ride to work. While the roads and highways are generally well maintained, the trains could make use of some upgrades. More and more residents complain about the frequent train delays and even cancellations. Although Paris has a regional express network, or RER, with 5 lines and 587 kilometers of rails connecting the city to the distant suburbs, there's no widespread network available. But it seems like Paris is finally taking definitive steps to resolve these issues in the form of a $45 billion transport project. Known as the Grand Paris Express, it aims to double the size of the existing metro. It's currently Europe's largest transport infrastructure project and the 4th largest on the planet. What exactly is the project about? Can it solve the issues of a metropolis already overburdened by foreign tourists? The Grand Paris Express will add 200 kilometers of tracks and 68 new stations. It is projected that it'll serve 2 million passengers a day. Under its name, 4 new metro lines, namely 15, 16, 17, and 18, will be constructed, while the existing lines of 11 and 14 will be extended. The idea is to better connect distant Paris suburbs to the city and each other, and in so doing, improve the commercial viability of its connected neighborhoods, business districts, and municipalities. 30% of it's being financed by the Société du Grand Paris, while the remaining 70% is by the local authorities through earmarked taxes, subsidies, and loans. Given the sheer scale of the project, there will be a big environmental cost as a result of its construction. But once in operation, the project's expected to become a very powerful saver of carbon, which is why Harvard University awarded it the 2023 Veronica Rudge Green Prize in Urban Design. For context, it's expected to reduce 14.2 million tons of carbon dioxide emissions by 2050. Line 14 North Extension included the development of an additional 5.8-kilometer-long tunnel featuring 4 new stations from Saint-Lazare to Marie-de-Sévigné. The extension became operational in December 2020. It'll be extended further, connect with the upcoming lines 15, 16, and 17 by 2024. The south end of this line will also provide a connection to Orly Airport, one of 2 airports in Paris. The most important of these lines would be Line 15, which will encircle the city and is divided into east, west, and south sections. As a high-capacity underground rail line, it provides a new ring line around Paris in the departments of Hauts-de-Seine, Val-de-Marne, and Seine-Saint-Denis. It will enable direct journeys between the suburbs, bypassing central Paris. Line 15 is planned to open in phases from 2025 through 2030, while east and west sections are expected to be operational by 2030. One of the stations on this route, Villejuif-Gustave-Roussy Station, is designed by Perrault Architecture. The station's located at an incredible depth of 50 meters, creating a massive multi-level cylinder of open-air space bathed in natural light. Villejuif-Gustave Station will also feature its custom artwork created by Chilean artist Ivan Navarro, who works with light and optical illusions. Once completed, the station will be no less than a spectacle. With 2 overlapping glass ceilings allowing in natural lights, the multi-story tunnel would be facilitated by several escalators for getting travelers down to the base level. And if you look at its design, it looks no less than a set from a Bond movie. Grand Paris Line 16 is a 46.67-kilometer-long line with 10 stations between Saint-Denis-Pleyel to Noisy-Champs. A section of Line 16 between Saint-Denis-Pleyel and Clichy-Montfermeil is expected to be operational by the end of 2026, while the remaining section till Noisy-Champs will be commissioned by 2028. With the news that Paris will be hosting the 2024 Olympics, it has put significant pressure on the authorities to deliver it way ahead of time, or at least some portion of it. Then President Francois Hollande and his predecessor, Nicolas Sarkozy, promised to make some portion operational in time, long before the city even won its Olympic bid. The promised portion included a full Line 14, plus a partial opening of Lines 15, 16, 17, and 18, which together connect to both Paris international airports. But when you're handling a project as massive as this, delays are inevitable. The Grand Paris Express is no exception, and it has experienced multiple delays over the years. Some of them were beyond their control. Floods, delays in equipment delivery, and perhaps most crucial of all, the COVID pandemic have slowed the progress. And 8 months before the 2024 Olympic Games, only the extension of Line 14 to Orly Airport is expected to open in time. The other lines will gradually come online starting in late 2025, according to the project's official website. However, the French Transport Ministry has still some progress to show. According to them, the new rail lines will increase transport capacity by 15% just in time for the game. This will come in very handy as millions of people are expected to turn up to an already popular summer spot. Interestingly, Paris's first ever metro was inaugurated in 1900 just before the Olympic Games. Line 1, which opened on 19 July 1900, connected Port de Mallet to the Port de Finchen and provided a service to the Summer Olympic Games organized by Bois de Finchen. Parisians fell in love with this new mode of transport, and its success resulted in additional rail tracks that would leave no point in Paris more than 500 meters away from a metro. It was among the world's first cities to have a metro system. Let's return to the express metros and take a quick look at their features. The average speed of the trains operating on the Grand Paris Express will be between 55 kilometers an hour and 65 kilometers an hour. The trains will also feature LED lighting, lights beneath the seats, USB sockets, internet connection, and space for wheelchairs and strollers. There will also be video surveillance to ensure security and prevent incidents. The important specs in the train will be marked with distinctive colors. That's not the best part yet. The train will be driverless and will include electric service braking. As sustainability has become at the forefront of every project in France, the Grand Paris trains consume less energy while also having effective heating, cooling, and ventilation systems. But let's not forget, it's France we're discussing, and as usual, art comes first. The Grand Paris Express will also be reflective of its rich cultural history. The Grand Paris Society decided to allocate a portion of its budget, roughly 35 million euros, to commission contemporary art for each station, creating a vast connected gallery made available to everyone with a subway ticket. It's a fantastic combination of art and architecture that's planned for each of the 68 stations. This takes us to the past where Hector Guillemard, a prominent figure in architecture, designed the iconic metro entrances. The previous RER trains that served the suburbs surrounding Paris also got a gorgeous makeover. The RER-C train, which transports passengers from the city to the Palace of Versailles, has been decorated on the inside with a plastic film featuring fountains, flowers, and furnishings from the palace and its grounds. Nothing better than a Versailles-themed train to take you to the Palace of Versailles. The grand new metro will reduce the number of cars on the streets, thereby reducing traffic congestion and pollution. Another way Paris is doing that is by encouraging more and more people to bike instead of drive. In 2007, Paris introduced Maglev, a successful bicycle sharing program. It now offers about 14,500 bicycles at 1,230 stations. Paris has been increasing its bicycle lanes since the late 1990s and now has about 700 kilometers of bicycle routes. Moreover, the city is also expanding electric bus lines. The goal is to make 80% of buses electric by 2025, and the rest will use biogas. Paris already has one all-electric line served by 23 buses. That's not all. Autoliv, an electric car-sharing service, offers 4,000 fully electric cars in the Paris region. It has 100,000 registered users ever since the beginning in 2011. These strategies seem to be working more and more as more Parisians are ditching cars and switching to greener transportation modes. The streets are finally reclaimed from the dozens of cars choking out fuel and engulfing the beautiful city. Residents can now finally take a sigh of relief and enjoy the stunning views the city has to offer. Do you think the Grand Paris Metro can solve the traffic issues of the city? One of the world's most ambitious construction projects is rising in the middle of a desert. The Gulf Cooperation Council, consisting of 6 of the Middle East's wealthiest countries, is building a railway over 2,000 kilometers long to better connect the region. This project faces immense challenges, from crossing desert sands to tunneling through mountains, and comes with a hefty price tag. The railway could unite the Gulf, reshape its transportation sector, reduce its carbon footprint, and spark a new era of economic development. But first, it must overcome political, financial, and logistical hurdles. Before diving into how this railway is being built, it's crucial to understand why it's being built in the first place. Let's start in February 1981 in Riyadh, Saudi Arabia. Leaders from Saudi Arabia, Kuwait, the United Arab Emirates, Qatar, Bahrain, and Oman gathered to form the Gulf Cooperation Council (GCC), a political and economic alliance. Their economies have thrived on oil and gas, making them heavily dependent on the oil market. During the Great Recession of 2008 and 2009, oil prices plummeted and the GCC economy suffered. This is where the railway comes in. In 2009, the GCC approved a massive railway project to link all 6 member states. The cost of this ambitious venture would be shared among the countries, with the entire project estimated to be between $100 and $250 billion. The goal was to diversify the Gulf states' economies away from their heavily reliance on oil and gas, which could help them build stronger, more resilient economies. The railway project aims to connect the nation's ports with manufacturing hubs and urban centers, creating a cohesive and efficient transportation network. This connectivity is expected to spur economic growth by facilitating trade, improving logistics, and enhancing accessibility within the region. A key component of the network is the Etihad Railway, an $11 billion, 1,200-kilometer freight and passenger railway stretching across the Emirates from the Gulf of Oman to the Persian Gulf. The railway is designed to play a crucial role in linking various parts of the UAE, enhancing both freight and passenger transport. The railway project is not just about transportation. It represents a strategic move to foster economic development and reduce the region's dependency on oil revenues. By connecting ports, manufacturing hubs, and urban centers, the GCC countries aim to create a robust infrastructure that supports industrial growth and economic diversification. Overcoming the immense challenges of building this railway, from navigating the desert sands to tunneling through mountains, will require significant financial investment and political cooperation. However, the potential benefits are substantial. The railway could unite the Gulf, reshape its transportation sector, reduce its carbon footprint, and kickstart a new era of economic development. The UAE's first national rail network is being built in 2 stages. The first stage, completed in 2016, covers 264 kilometers, connecting the Habshan and Shah areas in Abu Dhabi to the port of Ruwais. Working in this environment is tough, to say the least. During the summer, the heat can be so intense that some construction sites operate at night, when temperatures drop to around 30 degrees Celsius. Sand presents another major challenge, as it creates difficult shifting terrain. Etihad Rail has learned from other countries that have built in desert conditions, such as China, Saudi Arabia, and Mauritania. These nations have developed solutions like converting sand dunes to clay over many years, monitoring shifting dunes, and planting walls of vegetation to block wind and sand. To address the unique challenges of the desert, Etihad Rail's locomotives are equipped with a sand filtration system and a sand plow. These features help mitigate the impact of sand on the railway's operations, ensuring that trains can run smoothly even in the harsh desert environment. The second stage of the project is currently underway, aiming to extend the network and further enhance connectivity across the UAE. This stage will significantly increase the reach and capacity of the rail system, supporting the broader goals of economic diversification and regional integration. In Stage 1, Etihad Rail constructed 20 overbridges, 2 underbridges, 10 road underpasses, and 18 smaller underpasses for future use. The company also built 2 factories to produce concrete railway sleepers from locally sourced raw materials. Each sleeper is 2.6 meters long and weighs 340 kg, attached to the main rails with a fastening system to stabilize the track and ensure smooth travel speeds of up to 200 kilometers per hour for passenger trains. While this first route isn't transporting passengers yet, it carries up to 22,000 tons of granulated sulfur across 110 wagons daily. The sulfur is extracted from the fields in Abu Dhabi and processed for export at the port of Ruwais, where it is used to manufacture products ranging from batteries to fertilizers and fireworks. As of mid-2021, Etihad Rail has transported more than 30 million tons of granulated sulfur for the Abu Dhabi National Oil Company. A single train journey reduces carbon dioxide emissions by 70 to 80% compared to truck transport. This is significant for an economy with one of the highest carbon footprints in the world. This efficiency has also made the Emirates the world's top exporter of sulfur, bringing in $679 million in 2019. Much of that sulfur likely went to China, the world's largest importer of the element, which is also involved in Stage 2 of the project. Stage 2 construction began in 2020 and aims to extend the network by 605 kilometers, from Guifat on the Saudi Arabia border to Fujairah on the east coast. A $408.4 million contract was awarded to the China State Construction Engineering Corporation and South Korea's SK Engineering and Construction to design and build 139 kilometers of rail line. Once complete, the network will link the country's major industrial ports and trading centers, enabling the transport of more than 50 million tons of goods annually. This expansion is not only about improving transport logistics, but also about unlocking the potential for other natural resource developments in Saudi Arabia and the UAE, such as iron ore, gold, aluminum, and silver. A strong railway infrastructure would help these governments tap into these untapped natural resources, boosting their economies further. Professor Amory noted that such infrastructure is crucial for accessing and exploiting these resources efficiently. The project is set to transform the transportation landscape of the region, fostering economic growth and reducing dependency on oil and gas. By creating a robust and integrated rail network, the UAE and its neighbors are paving the way for a more diversified and sustainable economic future. Despite progress on the Etihad rail network, the broader GCC rail project has faced several hurdles. At one point, GCC countries temporarily excluded Qatar from the organization, casting doubt on its participation in the railway project. Moreover, the pandemic and fluctuating oil prices have caused logistical delays and led to cuts in infrastructure spending, pushing the project's completion date back by several years. Initially, the vision of Gulf leaders was marked by high ambition, sometimes bordering on unrealistic. Over time, this vision has shifted to a more pragmatic approach, focusing on achievable goals and practical solutions. This evolution reflects a growing recognition of the need to balance ambition with feasibility. Etihad Rail has not yet specified when the railway will be ready for commuters, but even when it is, there may be challenges in encouraging its use. In a country where cars are deeply ingrained in the culture, shifting public preference might take time. A 2020 survey by Road Safety UAE found that 83% of respondents rely on cars, while only 13% use public transportation. This indicates that promoting the railway as a viable alternative will require a significant cultural shift. Technological advancements can happen rapidly, but changing cultural habits, that takes longer. The railway project, while technologically advanced, will need to be accompanied by efforts to shift public perception and behavior towards sustainable transportation options. The potential benefits of the railway project are substantial. It promises to enhance connectivity across the Gulf, boost economic growth, and reduce the region's carbon footprint. As the network expands and becomes operational, it could gradually influence public attitudes, encouraging more people to embrace rail travel over car usage. This shift would contribute to long-term economic and environmental sustainability, aligning with the broader goals of diversifying economies and improving infrastructure in the GCC region. The construction of the railway network, especially projects like Etihad Rail, represents a crucial step towards these goals. Stage 2, which began in 2020, aims to extend the network by 605 kilometers, connecting key industrial ports and trading centers across the UAE. This stage involves significant international collaboration, with a $408.4 million contract awarded to China's State Construction Engineering Corporation and South Korea's SK Engineering and Construction for the design and construction of 139 kilometers of rail line. The challenges of building in the harsh desert environment, from extreme heat to shifting sands, are being met with innovative solutions and lessons learned from other countries with similar conditions. These efforts underscore the determination of the Gulf states to realize their vision of a connected, diversified, and sustainable future. The project's success will depend not only on overcoming these physical and logistical challenges, but also on fostering a cultural shift towards embracing public transportation. As the railway network continues to develop, it holds the promise of transforming the transportation landscape of the Gulf, paving the way for a more interconnected and resilient region. Still, the railway is a significant part of the Gulf nations' plans to become more sustainable and diversify their economies. This project has sparked a new industry, creating numerous job opportunities. Both Saudi Arabia and the UAE have developed rail studies training programs to support this growing sector. The Gulf economies have seen exponential growth over the last 3 decades, and the development of railway lines is a logistical extension of this immense economic expansion. The Emirates, known for its oil wealth and futuristic development, is using the Etihad Railway project to showcase a long-term strategy aimed at building a more connected and unified Gulf region. While the glitzy skyscrapers and luxurious lifestyles often dominate perceptions of the Gulf, the railway project highlights a commitment to sustainability and economic diversification. It reflects a broader vision to reduce dependence on oil and promote a more resilient and interconnected regional economy. The Etihad Railway, along with the broader GCC rail project, is poised to transform transportation across the Gulf. By improving connectivity between major industrial ports, trading centers, and urban areas, the railway will facilitate trade, enhance logistics, and promote economic growth. This infrastructure investment is also expected to reduce carbon emissions, aligning with global sustainability goals. As far as technological advancements go, China is pretty far ahead. They achieve architectural marvels that seem impossible to other countries. I mean, this is a country that rebuilds an entire bridge in 24 hours, and it's as if nothing happened. Now China has another mega project, which is the China-Nepal Railway. This is a railway unlike any other, going for so many miles. However, that's not the most shocking thing about it. This railway is expected to go through the Great Himalayan mountain. And if you think they can't do it, then be ready to be amazed. But what is it exactly about this tunnel and railway line that makes it so unique? Well, let's find out. At the point where China's Tibet, Pakistan, India, Nepal, Bhutan, and other nations converge, there lies the world's highest mountain range, the Himalayas. This is a mountain range with spectacular landscapes and captivating glacier views. This has been one of the most coveted destinations for many adventurers and explorers. However, under all these towering peaks, one of the most remarkable projects in the history of transport is taking place. A team of China's construction workers is building a super tunnel that spans about 18.6 miles or 30 kilometers through the mountain. This tunnel is set to be used for state-of-the-art railway tracks. And given China's success with such insane projects, this is just another mere tunnel construction project for them. But why is China really focused on building this railway line? And how will they build this massive tunnel? Plans for this tunnel all started on August 8, 2022. This was when the foreign minister of Nepal visited China, and during the talks, Nepal expressed interest in establishing a comprehensive interconnected transport network with China. This network, which is the ongoing China-Nepal Railway, spans across the Great Himalayan landscape. However, this is not the first time such a concept has come up. However, this concept has existed for more than 4 decades. This was around the time when China's Mao Zedong extended an infrastructure commitment to Nepal, but it took all those years before the actualization of this project started. But why wait so long before starting this project? To understand the long delay, we have to look at the past a bit. You see, China and Nepal have faced a couple challenges in the past, and most of them were technical and financial. Because of this, they had to put a pause on the complex railway endeavor. However, China has since seen its infrastructure capabilities improve and evolve. With this, a significant investment of $4.3 billion by China was made to facilitate the construction of the China-Nepal Railway. This was in the year 2022. On the other hand, Nepal seems to really want this to work. This is because Nepal, on its own, is a landlocked country. This means they have had transportation issues. On the other hand, the mountainous terrain handlers travel locally, which has ended up restricting the nation's economic and trade development. Apart from connecting China to Nepal, the completed railway will also connect 3 major cities within Nepal, making commuting between them easier. In addition, Nepalese people will have a third option apart from roads or planes when going abroad. One of the designated sections of this insane project within China's borders meanders across the Tibet Autonomous Region. In the first half of 2022 alone, the region has seen more than 17 million tourists. Even if we assume that only 1/10 of these travelers visited Nepal by train via Tibet, Nepal's tourism industry would still see impressive growth with this project. Another benefit of this new railway is that it'll reshape Nepal's dependence on India for maritime transport. And with this, the country would grow both in foreign trade and socioeconomics. Laos, another landlocked country, would also benefit from the railway system, which would see its market structure grow. This is all thanks to it securing a major transportation channel through the China-Laos Railway project. Similarly, the China-Nepal Railway will also fuel Nepal's national development, allowing its citizens to enjoy the benefits of development. The China-Nepal Railway is currently one of the most formidable railway projects in the world. This project will go through the Himalayan region, encompassing seismic zones and glaciers. However, throughout the construction, the workers will have to deal with a number of unforeseen challenges. Among them are harsh weather conditions and the threat of mudslides. Taking all these factors into consideration, the project becomes even more complicated. According to some scientific expeditions, it's been found that there have been more than 1,000 mudslides along the railway route in recent years. But it gets worse. Some areas have experienced as much as 1 mudslide per kilometer. This definitely makes the construction of the China-Nepal Railway even more intricate. Because of this, the team behind the construction has to come up with ways to deploy advanced technical methodologies and meticulously crafted design strategies if they're to uphold the paramount aspects of construction quality and safety. This new railway will extend the Rigi Railway, which is a branch of China's Qinghai Tibet line that goes into Nepal. A look at the project plan reveals that the China-Nepal Railway will be about 335.5 miles or 540 kilometers long. It's set to start in Tibet, China, and extend all the way to Kathmandu, the capital of Nepal. It's expected to take 10 years for it to be complete. However, the Chinese might surprise it and finish it even before 10 years. One of the most astonishing things about this railway is that it comprises 98 segments. These segments are made up of bridges and tunnels. And among these tunnels, 45 will go through the famous Himalayan mountains. However, the greatest challenge the construction team will encounter is getting these segments through the Mala Mountains, an offshoot of the Himalayas. This will involve constructing an insane tunnel through the Mala Mountains, which has been given the name the Himalayas Tunnel. It goes without saying that the Himalayas have been known as one of Earth's most loftiest mountains, and very few inhabit them. This is because of the impressive nature here, and to even think of creating a tunnel through an entire mountain is a great task on its own. I'm sure you can already imagine how much they'd have to do for this to be successful. To ensure that the China-Nepal Railway passes through these towering peaks, China initiated the construction of the Himalayas Tunnel in February 2023. 5 months into the excavation, the construction team had managed to excavate a total of 1.04 miles, 1,680 meters. This was pretty fast, given that other nations like the US, Germany, and other developed counterparts would take about a year to achieve this. However, as much as it is a significant milestone, it represents merely a fraction of the entire tunnel project. According to the blueprint, the Himalayas Tunnel is estimated to be about 18.6 miles or 30 kilometers long. So they still have a very long way to go. It's been reported that China is planning to invest more than $1.4 billion in this project. This gives an average of $46 million per kilometer. Interestingly, when you compare this to the cost of the world's longest railway tunnel, the Qatar Tunnel, you can see China's infrastructure initiatives' efficiency and scale effect. The Qatar Tunnel was estimated to cost about $198 million a kilometer. However, China's infrastructure projects are known to offer superior cost effectiveness and scale compared to those of other nations. And with the present construction speed, it's been estimated that the Chinese construction team might be done with the Himalayas Tunnel by December 2024. However, the construction of such a massive tunnel has its challenges. Firstly, the tunnel's set in a high-altitude, cold region. This brings about significant obstacles to engineering operations. The greatest one is the lack of oxygen as they go deeper. According to geographers, the oxygen concentration in the air and at altitudes that are more than 15,000 feet or 4,800 meters above sea level is less than half that found in lower regions. And so to see the tunnel to completion, the construction team has to sustain regular work routines as they ensure a steady supply of oxygen through specialized generators. Ultimately, to make the process faster and more efficient, the construction team deployed the Jinhua Shield machine, a marvelous creation conceived and developed within the country. This incredible machine boasts a diameter of 52.7 feet, 16.07 meters, and a mass of 4,300 tons. It's pretty powerful, given that it can excavate a tunnel segment equivalent in height to almost 6 stories in a single operation. This machine's been a crucial instrument in constructing the Himalayas Tunnel. The machine comes with forward cutting blades and cutting-edge technology that cleaves through soil layers like a piece of cake. Concurrently, it disposes of the excavated earth through a conveyor belt mechanism. The shield machine has been built so that it digs further. A reinforced support system comes into play. This system applies precast concrete lining, which has been augmented by integrating steel sheet piles and sturdy steel arches. The entire project is unlike any other. However, we can be sure that China will definitely achieve this, maybe even before the estimated period. What do you think of the Himalayas Tunnel? Do you believe that the railway will influence other countries' rail systems? Imagine you're a businessman who wants to ship goods from Europe to Southern California. How would you go about it? There are a few options. One's to use the Strait of Magellan, which is a narrow water passage in Chile connecting both the Pacific and the Atlantic Oceans. But let's remember that you have to navigate all the way through the southern tip of Southern America and then all the way up to California. That would simply take up a lot of time and other resources like fuel. The second, more acceptable option would be to use the Panama Canal, as the majority of the businesses use it. However, the catch is that this 50-mile canal is facing a major drought that has slashed its ship crossing by 36%. The precious Panama manages 6% of the world trade and right now is heavily crowded with vessels in the waiting line for 20 to 21 days. Luckily, another option now exists. It's called the Inter-Oceanic corridor in Mexico. This corridor is created at the narrowest point in southern Mexico, the Isthmus of Tehuantepec. For those who don't know, an isthmus is a narrow strip of land that connects two larger pieces of land, flanked by oceans on both sides. This will bridge the gap between the Atlantic and the Pacific Oceans, connecting the ports of Coatzacoalcos and Salina Cruz. While the Panama Canal takes anywhere from 8 to 10 hours to transport a single ship, the Inter-Oceanic corridor will take 6.5 to 7 hours, excluding load time. The corridor would be 188 miles long, featuring both freight and passenger services. Launched in 2018 by Mexican President López Obrador, the aim was to bring economic prosperity to the often neglected southern portion of the country. The project will create 10 industrial parks designed to attract investment in Mexico's poorer and less developed southern region. By 2028, the corridor will be used by 300,000 cargo containers, and by 2033, that number is expected to more than double to 1.4 million vessels a year. The government's announced an investment of $2.85 billion in the project. According to project coordinator Adiel Estrada, the railway link has created 800 direct jobs and some 2,400 indirect ones. Once fully developed, it has the potential to contribute between 3 to 5% of Mexico's GDP. With the backing of the U.S. and the strong support of Asian countries and 65 foreign companies, the Inter-Oceanic Rail might come to haunt the Panama Canal. After all, Panama's facing serious issues due to severe drought that's dropped the water level by several feet. Can the Inter-Oceanic link beat the centuries-old and trusted Panama Canal? Stay with us till the end to find out. Plans to connect both oceans and the Isthmus of Tehuantepec has existed since the 16th century when Mexico was a Spanish colony. Due to the short distance between the two oceans in this area, the potential for the creation of such a project had been attracted to various global powers, including Spain, England, France, the Netherlands, and finally the United States. Building a link between both oceans would save cost, product, and time. And let's not forget, since it was the 16th century and transport wasn't modern, it would have also reduced the risk of losing cargo ships attempting to reach the other side of the Americas. In 1774, the Spanish authorities conducted geological research in the isthmus that allowed Mexicans to create a canal, but this would not occur until Mexico became an independent country in 1821. Shortly after independence, the Mexican government conducted its surveys in the region, and the survey teams proposed building a railway instead of a canal. However, the plan couldn't be executed due to the economic crisis during that period. Despite the several failed attempts and promises by rulers to deliver the railway project, this all changed when dictator Porfirio Diaz came to power. Now that Mexico had political stability and a strong standing army, the Tehuantepec Railway could finally be completed. On 23 January 1907, the railway, along with the ports of Salina Cruz and Coatzacoalcos, were inaugurated by President Diaz. The inauguration was celebrated with a transportation of 11,500 tons of sugar from Hawaii. Up until that point, the majority of the ships had been using the Strait of Magellan to transport cargo from New York City to other ports in the Pacific. The Mexican railway changed all that. For the first 6 years, the railway seemed to be highly successful and provided a significant economic boost to Mexico. Throughout that period, it transported over 850,000 tons of cargo across the two oceans. However, the success of the project was short-lived due to two reasons. The first was the opening of the Panama Canal by the U.S. in 1914. This proved to be disastrous for the Mexican railway, as Panama attracted the majority of the maritime traffic. Since Panama was a U.S. project, American businessmen preferred using it over their Mexican counterparts. In that year, the cargo of the railway fell by a third, and then the following year by 77%. But the second reason proved to be more deadly than Panama itself. By 1910, Mexico had become engulfed in the largest civil war in its history, the Mexican Revolution. Railways across the country started to be used almost exclusively for war, including the Tehuantepec itself for transporting the rebel troops. At the same time, the Panama Canal continued to flourish, cementing its place in the global maritime trade. As of now, a total of 40 ships pass through its ship locks daily, earning $3 billion annually. But this all went south when a severe drought hit Panama in early 2023. In October, rainfall was 43% lower than average levels, making it the driest October since the 1950s. Each ship requires a staggering 200 million gallons of freshwater to move through the canal's locks. To save water, the number of ships has been reduced from 40 per day to 24 per day. On top of this, we have a long wait time even after ships have paid a heavy fee for pre-booking slots. According to one shipbroker reported by S&P Global, the pre-booking cost $40,000, and since their vessel couldn't make it on time, they had to swap it with another, but that too cost an additional $16,000. Waiting time for northbound ships has increased to 20 to 21 days, and the southbound ships have to wait 18 to 21 days. Initially, a $200 million loss was estimated, but since the condition hasn't changed much, we're now looking at a $500 to $700 million loss. But as the famous Indian saying goes, even a dead elephant's worth a lakh rupee. And the Panama Canal isn't going anywhere anytime soon. With that, we arrive at the most important question of the hour. Can the Mexico Inter-Oceanic Rail beat the Panama Canal? To answer that, there are a few factors to consider. First of all, a cargo ship and a freight train have different capacities. While a ship can carry 15,000 containers, a railway can carry 2,000. This means that the Inter-Oceanic link can't handle the amount of maritime traffic that Panama efficiently manages. That's why even at its maximum capacity, its annual cargo would only be 10.5% of the total goods transported through the Panama Canal in 2022. The second reason being inconvenience. With a railway transport, the incoming ships have to offload their cargo and load it onto the freight trains which carry goods to the other side. On the other side, the cargo once again has to be loaded onto the vessels which carry them to the final destination. That's why the success of this project depends on the implementation of cutting-edge technology at the ports of Coatzacoalcos and Salina Cruz, as well as on the railways. This technology must be capable of handling and transporting an immense volume of containers efficiently, ensuring seamless movement between the ports. Achieving this goal requires collaboration between the government and the private sector. With that being said, the Mexican Inter-Oceanic Railway wouldn't be a replacement, but rather a complement to the existing Panama Canal. Even if Mexico takes 10 or 15% of the load, it'd solve delays and congestions that can benefit everyone. Under the railway project, there will be 3 lines, the most essential being Line Z. It stretches up to 132 miles and connects the ports of Salina Cruz, Oaxaca, and the Veracruz. Line K will connect the cities of Ixtepec, Oaxaca, and Ciudad Hidalgo, and the Guatemala-Mexico border. Line FA is 204 miles long and will connect the states of Veracruz, Chiapas, and Tabasco, with the ports of Dos Bocas, Tabasco. Much of the project revolves around the rehabilitation of the old railway line built under Porfirio Diaz, but modified for the current need. The ports of Coatzacoalcos and Salina Cruz will both be modernized and expanded. New highways are being built and the customs departments being improved for enhanced efficiency. In December 2023, Line Z was inaugurated by President Lopez Obrador. In Salina Cruz, a new port with an access depth of 79 feet and a breakwater has just been completed. With the inauguration of the Salina Cruz breakwater, the president promised that this would enable enormous ships to access the port. The dry corridor offers a promising alternative to traditional routes like the Panama and Suez Canal, utilizing its geographical position to its advantage. Using this and many other mega projects, Mexico has the potential to become a major logistics hub, serving not only North America but the global economy. What do you think about the Inter-Oceanic Railway? New York State is, without a doubt, one of the cornerstones of American civilization, so it's hard to believe that this region's served by a decaying railway system. The Northeast Corridor is the longest electrified rail corridor, spanning up to 8 states from Washington, D.C. to New York to Boston. This 457-mile-long corridor is utilized by both passenger and freight, as well as intercity travelers, serving 17% of the U.S. population. Dubbed the busiest railway line in the country, it supports more than 2,000 trains with 800,000 daily passengers. The portion of the Northeast Corridor between Newark, New Jersey and Penn Station is 10 miles long and carries over 200,000 daily on Amtrak and NJ Transit passenger trips. It has only 2 tracks which support approximately 450 trains, while a majority of the remainder of the Northeast Corridor has 4. The 2 tracks mean that there's a traffic bottleneck in one of the most vital arteries of the region. Picture this: if even one of those tubes under the Hudson River becomes unoperational, it'll cause a $16 billion loss to the nation's GDP and add 30 minutes of travel time in an already congested railway station. At this point, it's very much in America's interest to make travel fast and headache-free in such an essential economic region. The Gateway program will replace and update rail infrastructure assets that, in many cases, are over 100 years old. The 2-track rail line used by Amtrak and NJ Transit Rail Operations, NJT, has reached its full capacity of 24 trains per hour. To increase the railway capacity of this section of the corridor, there are several expansions planned. This includes 1. A new tunnel under the Hudson River, 2. Stabilizing the existing 100-year-old tunnel under the Hudson, 3. New tracks and platforms to be placed on Penn Station in New York, 4. Replacing the Portal Bridge and Sawtooth Bridges in New Jersey. These modifications and several others come at a staggering cost of $16.1 billion. But this price tag seems to be worth it, as this project will reduce travel time, inject $85 million a month into the economy, and create 72,000 jobs. The construction will also utilize U.S. suppliers and manufacturers. More than just stimulating the economy, the Gateway program will eliminate 2 million tons of CO2 from the air. In the beginning, New York and New Jersey were going to divide the project expense, but luckily they'll be saving a few bucks as the government stepped in. As of now, the majority of the expenses will be covered by the federal government. Under the Infrastructure Act, the project received an additional $3.8 billion.
Today's 3.8 infusion follows other funds I announced previously and brings the federal total to over $11 billion.
Consequently, both New York and New Jersey only have to contribute 15% to the Gateway program. The project was proposed in 2011, but it took nearly a decade to convince politicians and federal agencies to fund this cause. In 2021, it was formally approved by the federal government. Work officially began in 2023, although the completion is set for 10 to 12 years later. The first phase of construction includes creating a 2-track tunnel under the Hudson River and replacing the obsolete Portal North Bridge with an elevated one. Let's start with the existing tunnel under the Hudson River called the North River Tunnel. The North River Tunnel is in a desperate need of renovation, not just because it was built in 1910, but also because it was heavily damaged in 2012 by Superstorm Sandy. The intense flooding filled the tunnel with millions of gallons of salt water, which led to disabled trains, signal malfunctions, and delays. The magnitude of this damage created an urgency for its speedy refurbishment. In May 2014, Amtrak stated that within 20 years, one or both of the tunnels would have to be shut down, as they are more or less operating at full capacity. The Pennsylvania Railroad started construction in 1903, and it was open to the people in November 1910. The tunnel was considered state-of-the-art by the standards of the 20th century, but not so much now. It's a simple one-track in, one-track out system connecting New York and New Jersey. The tunnel was created using cast iron tubes, and they lie 20 feet below the riverbed and sill. The neglected walls are unable to stop the saltwater from intruding into the tunnel. The continuous leaking of saltwater has damaged the concrete, which is now falling apart. Inside the tunnel, 2 bench walls run on both sides. These bench walls are also corroding. It's important to note that the bench wall has ducts that store the power cables that serve the trains and Penn Station. The final nail in the coffin was Superstorm Sandy. It left behind a large residue of salt on the cement walls, decomposing them over time and eroding the copper cables. As such, there's very limited flexibility when incidents occur in the tunnel. The new 2-track tunnel will be constructed between Bergen Palisades in New Jersey to Manhattan. So now instead of 1 tunnel, you got 2 tunnels under the Hudson River. Just like the North River Tunnel, the Portal North Bridge is also more than a century old and in dire need of replacement. It's a movable swing-span bridge that crosses over the Hackensack River, taking trains into and out of New York. Being a critical link of the Northeast Corridor, it carries 450 Amtrak and NJ Transit trains each day. Due to age and fragility, trains are restricted to a maximum of 60 miles an hour over the bridge. As it is movable, it can open and close to allow maritime traffic to pass through. However, its electrical and mechanical components malfunction often, delaying the opening and closing of the trains. That's why engineers thought it would be best replaced by a modern, more reliable fixed-span bridge. The new bridge would be much higher over the water, allowing boats to pass underneath without the need to open and close. It'll have higher speeds along with increased capacity and save millions of dollars in maintenance costs. In the same fashion, a second bridge called the Portal South Bridge will stand alongside the North Bridge. The South Bridge will also feature a 4-track like the rest of the Northeast Corridor. Phase 1 also includes the construction of a concrete casing on the west side of Manhattan and Hudson Yards to preserve the right-of-way for the future tunnel to Penn Station in Manhattan. Interestingly, before the Gateway project was even a thing, a similar project called Access to the Region's Core was being pitched. Although the idea was scrapped, this plan similarly aimed to create a new tunnel, a new rail yard, and a subway. A new station adjacent to the New York Penn Station was to be constructed, as running more trains into the current station was deemed unfeasible. An estimated budget for the project was $8.7 billion. Construction began in mid-2009 and the project was slated for completion in 2018. But in a shocking turn of events, it was canceled by Chris Christie, the governor of New Jersey, who cited the possibility of cost overruns and the state's lack of funds. But what's sadder is that $600 million had already been spent on that project. This decision remains controversial till today. The future phases of the Gateway program will replace and expand the Sawtooth bridges on the Penn Station in Manhattan. In late 2023, Amtrak, in coordination with New Jersey Transit, began the procurement process for the Sawtooth Bridge's replacement. This replacement program will preserve and expand its capacity. The new bridge will feature a 4-track structure which will double the capacity in one of the most congested and complex locations on the corridor where these different services all come together. The Federal Railroad Administration, FRA, recently awarded this project up to $133.32 million in grant funding to support early construction activities. The Sawtooth bridges are owned by Amtrak and are used by 400-plus trains a day belonging to the New Jersey Transit, PATH, and Conrail freight train. In addition, Penn Station's also due for a multi-million-dollar overhaul. It's one of the busiest transit stations in the world, seeing an average of 650,000 visitors passing through its halls on a daily basis. Its 21 tracks accommodate approximately 1,300 train movements each weekday. The reconstructions needed to correct the substandard conditions experienced by hundreds of thousands of customers at Penn Station. The project will add at least 9 new tracks to the station, increase the number of entrances, and provide more accessibility options. Moreover, new platforms, railroad systems, passenger concourses, underground connections, and support services will be added to the station. Overall, this expansion will allow more than a doubling of peak-hour passenger trains once future capacity improvements are constructed. Another target of the Gateway program is the Dock Bridge. It crosses the Passaic River in Newark, New Jersey. Made operational in 1935, this 90-year-old structure is in for repair. Since it's a movable bridge, the plan is to convert it to a fixed bridge to reduce delays. The project would also repair the bridge's steel and concrete and remediate and repaint its structure. Officials at the Gateway Development Commission have publicly stated that by 2038, they'll have finished digging and constructing the new tunnels and then rehabilitating the 2 existing Trans-Hudson tubes. However, the audit performed by the U.S. Department of Transportation's Transit Administration shows that this work will likely take until 2040. The complicated geography of the Hudson River poses a challenge to human ambitions and requires substantial prep work. Despite the setbacks, the Gateway program was a much-needed step towards streamlining travel in a region that contributes almost 20% to the GDP and hosts 97 of the 500 Fortune companies. It's a critical element of the nation's transportation network, linking millions of people to good jobs and connecting this region with the rest of the country. What do you think of the Gateway program? Will it solve New York's traffic problems?
वहीं पर होगी जहां high-speed corridor honge.
As the 5th largest economy in the world with an enormous population of 1.4 billion, India appears as a prominent country on the map. The Indian Railways, or IR, operates 12,600 trains to carry over 23 million passengers daily. For context, this is equivalent to moving the entire population of Australia regularly. With over 7,000 stations spread across the country, India has the largest rail network in Asia and the 3rd largest on the planet, with a length of 42,280 miles. That's not to say that it comes without its share of problems. Let's take a look at some of the challenges that the Indian Railway faces today and whether they can overcome them. Will a mega project like a bullet train project help India become a global superpower? Starting with the most obvious issue, overcrowding. There's a mad rush for trains on high-density routes, particularly during weekends, major festivals, and summer holidays. The station's jam-packed hours before the train arrives, and when it does, all hell breaks loose. The trains are filled 4 times their capacity, with people being forced to either stand or sit in passages or even occupy toilets. Those who buy tickets for unreserved seats most of the time don't even get a seat, as there's a swarm of ticketless commuters. As the fares have been kept low, the railways become a lifeline for the working-class communities, with carpenters and masons using it frequently to travel for seasonal work. The Indian Railway prides itself on being the cheapest form of transport, as it bears 53% of the passenger cost. In 2021-2022, the railways spent INR 602,170 million on subsidized travel. While it may benefit local travelers, the department's incurring financial losses, which further hampers its success. The railway's IT systems are so slow that they can process only 25,000 bookings per minute, making it an impossible task to get a reservation on a busy train. Officials are working to increase the bookings capacity to 225,000 per minute. Then there's the issue of delays. Research done in 2017 found that the average train was late by 53 minutes, making 30% of trains late in this period. Improper infrastructure, like the unavailability of platforms with sufficient length, lack of stabling, and washing pit lines, are the main reason behind the delays. Due to less capacity of platforms, The trains have to wait at the outer signal or the adjacent station until it's vacated by preoccupied trains, leading to a 15-minute delay per train. But that's not the worst part about the Indian Railways. It's the loss of thousands of lives due to train-related accidents every year. According to the National Crime Record Bureau's 2022 report, more than 100,000 train-related deaths were reported between 2017 and 2021. These include collisions, people being run over, and passengers falling from trains. A staggering 69% of these incidents are caused by derailments. This shows that fixing tracks and related infrastructure should be the top priority of the authorities. In June 2023, India saw its worst train crash in 20 years, killing 261 and injuring 1,000 people in the Odisha state. A passenger train traveling from Calcutta derailed after hitting a stationary goods train. However, several of its coaches ended up on the opposite track. Unfortunately, the Howrah Superfast Express, which was traveling in the opposite direction, hit the overturned carriages. The force with which the trains collided with one another resulted in several coaches being crushed and mangled. With the development of highways, most citizens are utilizing cars or buses instead of the chaotic railways. The most obvious downside of both of these is that they take more hours than the train to reach their destination. Surely, millions of Indians require a safe, efficient, and more comfortable mode of transport for their daily lives. The development of a high-speed rail network is also crucial if India truly wants to become a global superpower. In fact, its regional partners like South Korea, China, Japan, Indonesia, and Russia have developed their bullet train systems, so why should India lag behind? To solve this, the government's starting to take steps in the right direction. And while a widespread high-speed rail network isn't currently available, there are subsections of the country that have it. For example, the Vande Bharat Express is a semi-high-speed electric rail operating in major cities like Mumbai, Chennai, and New Delhi, among others. Its top speed was set at 100 miles an hour, but due to traffic congestion and the speed limit of the tracks, it operates at 99 miles an hour. India made global headlines when it inaugurated Vande Bharat in 2019, as it set the country's first indigenously designed and manufactured semi-high-speed rail set. Nevertheless, it's safe to say that it's a lot better than the conventional railways. With state-of-the-art facilities like automatic doors, onboard Wi-Fi, GP passenger information system, and 30% less energy consumption, it's a first for Indian Railways and the whole country. But it seems like India's not stopping anytime soon. The Railway Ministry set another ambitious project to make the country's first bullet train. This project is a partnership between the Indian and Japanese governments, with the latter providing funding and technical assistance. Built on the Japanese Shinkansen-style model, the project costs a whopping $14 billion, 81% of which will be provided by Japan as a 50-year loan on an interest rate of 0.1%. The bullet train consists of 24 train sets that'll cover the 332-mile route between Mumbai and Ahmedabad. This high-speed train will cover the distance in just 2 hours compared to the Ahmedabad Duronto Express, which takes 6 hours and 15 minutes and is currently the fastest way to reach Mumbai from Ahmedabad. Mumbai is the financial hub of India with a huge population of 22 million, the largest in any city. On the other hand, Ahmedabad is the biggest city in the state of Gujarat. Because of its rich culture and history, Ahmedabad has many tourist landmarks and is also an emerging center for education and technology. Connecting these two megacities is not only beneficial for the economy, but also for boosting tourism. The bullet trains will run at a top speed of 200 miles an hour with 12 stations in between the routes, 8 of them being in Gujarat. Just like any other mega project in the world, this one too was conceived many years ago. In 2009, 5 high-speed rail corridors were proposed for a feasibility study. A 400-mile-long high-speed rail corridor was proposed to run from Pune to Ahmedabad via Mumbai. A memorandum was signed in New Delhi between the Indian Ministry of Railway and the French National Railways. Both parties agreed to carry out jointly an operations and development feasibility project on this inner-city route. In March 2013, it was decided to drop the Pune system of the network and only focus on Mumbai and Ahmedabad. This decision was taken due to money troubles, as the mountain range between Mumbai and Pune would increase the budget of the project. Since a very little portion of Maharashtra was being covered, the state government was reluctant to bear the financial burden for this subsection. However, some progress started in May when Japan entered the picture. Both the Japanese and Indian prime ministers agreed to co-finance a feasibility report for a railway system with a speed of 190 to 220 miles an hour. The report investigated traffic forecasting, environmental challenges, and the overall engineering requirements for this particular terrain. The survey team recommended bullet train models with automatic control systems and dedicated tracks. Many of these tracks will run parallel to the existing railway tracks in the area. Initially, the construction was expected to be completed by 2023, but due to delays in acquiring land in Maharashtra, the deadline was pushed by 5 years to 2028. Let's talk about the engineering that went into this multi-billion project. The corridor will originate at the 3-story underground station in Bandra Kurla Complex, BKC in Mumbai, and will only see the light of day when it arrives at Thane. The terminal at BKC would also connect Line 3 of the Mumbai Metro. Mumbai Metro is an underground metro service under construction and will be a first for India once completed. This would help travelers from South Mumbai to reach the terminal. Each train will have between 10 and 16 coaches. The passenger capacity of each train would be between 1,300 and 1,600. Coaches will be equipped with multi-purpose rooms that contain foldable beds for feeding mothers and patients, and the rooms will also be fitted with mirrors and baggage racks. In addition, extra space would be provided for heavy luggage at the end of each coach. This modification isn't found in the original Japanese design. 90% of the tracks will be spread on viaducts, 5% in tunnels, and almost 2% on bridges. Even though the elevated infrastructure costs an additional $1.3 billion, it saves the railway's legal troubles revolving around land acquisition and the need to build underpasses. The environmental impact is also significantly reduced, which is great for areas with thick vegetation and wildlife like Thane. The National Board for Wildlife gave conditional approval to cut down 32,044 mangroves, provided that safe passages and noise barriers for animals will be erected before the construction. All of this seems simple in theory, but that's not the case in reality. The biggest challenge is posed by Thane Creek, a large inlet of water standing in the way of construction. Instead of building high above the surface, it was proposed to build an undersea tunnel, the first of its kind in India. This was done to avoid damage to the thick vegetation present in the area. The 13-mile tunnel, 4 miles of which will be below sea, will connect Thane and Virar. As the route traverses many villages, there were protests by local farmers who were against giving up land for this modern amenity. In 2020, Maharashtra Chief Minister Uddhav Thackeray even called the project a white elephant and questioned whether anyone would benefit from it. Many citizens were skeptical about this costly venture as they believed that this money could be used to redevelop the existing railway system. However, all these disputes seem to be settled by 2023, as 100% of the land was already acquired in Maharashtra, while 98% in Gujarat. Currently, the project is standing at 30% completion. The Gujarat section of the corridor is completed by 35%, while the Maharashtrian side is lagging behind at 19%. For better or for worse, this project will completely transform the social scene, turning the 7th largest country into a small village. The most apt example of this is Japan, which completely revolutionized itself with the inauguration of the bullet train in the 60s. Recovering from the traumatic World War II, these trains were a symbol of Japanese resilience with benefits like job creation, enhanced mobility, and increased efficiency. India could replicate the same model and with Japan on its back, can become a global superpower in the future. This project is in line with the Made in India initiative, which focuses on bringing international investments and upscaling the manufacturing sector. With global analysts like Goldman Sachs suggesting that India might become the world's 2nd largest economy by 2075, it's only a matter of time before it happens. But for the time being, India's ground reality is quite different. More urgent issues like poverty, illiteracy, unemployment, pollution, healthcare, etc. continue to plague the country. That's why the strongest critics of this project believe in prioritizing other issues instead of accumulating billions of dollars in loans into futuristic builds like these. Do you think that the bullet train is the right investment for the Indian people? Will solving transportation issues help India become the next superpower? It almost seems like a joke that the richest economy in the world, the US, doesn't have a single high-speed rail. High-speed trains have proved their worth worldwide over the past 50 years. Europe, Japan, and China are leading the game in this domain. But it seems like this revolution bypassed America completely. Despite being one of the world's first countries to get high-speed trains, it failed to spread out. As of 2022, China had by far the longest high-speed railway network in the world, with almost 25,000 miles of high-speed rail lines. It's followed by Spain and Japan with more than 1,800 miles of high-speed rail each. So why is America lagging in this area? Is it the American love of cars, or is it deep-rooted in economic or political troubles? Well, the answer is both. The first reason? Building a railway isn't cheap. To build a railway line, you have to secure land in a straight path, as you can't run trains at high speeds along a curved path. The U.S. has very strong property rights, which make land acquisitions a legal and financial challenge. Back when it was so cheap to secure land, the U.S. had no problem building train tracks across the country. Compared to China, where the state controls much of the land, securing land's relatively easy. Secondly, the love of cars is deeply ingrained in the average American. Films like Ford vs. Ferrari and Fast and the Furious are a reflection of the public interest. Moreover, the U.S. invests billions in the interstate highway system for regular maintenance and expansion, further cementing the importance of car travel. Then we have some legislation that shaped the course of history. Trains lost their luster after World War II when federal legislation favored private cars and commercial jets. In the 1950s, then-President Eisenhower signed a Federal Aid Highway Act that allocated $25 billion for the expressways. In 1958, airplanes dominated the scene as the Federal Aviation Administration was created to promote fast and safe air travel. Another factor is the ease of acquiring cars in comparison to other nations. Unlike the US, other countries tax heavy amounts on car purchasing to keep demand in check. For example, in Singapore, car buyers must pay an additional 150% on top of the price of the car in excise and registration duties. This discourages people from buying cars and resorting to cheaper modes of travel like high-speed railways. In a society where there are fewer cars, the demand for public transport will organically be higher. In America, 91% of households own at least one car, with Idaho and Wyoming having the highest rate at 96%. But it seems like the car fever is slowly and gradually dying down. But perhaps the most powerful factor is the expansion of cities. During the pre-automobile era, residential and commercial structures were close to each other, so people could reach places by walking. But with a growing need to accommodate the increasing population, suburbs are built at greater and greater distances from the train station. So even if you do arrive in a city by train, you still got to use a car to get around. Furthermore, most cities don't have a convenient metro system to carry people to their destinations. That's why most people opt for traveling by car all the way through. The already few existing railways are underutilized, and that's because of the way that the tracks are laid out. If you look at the network of Chinese railways, you'll see a giant web. The railway net is spread on all corners so that there's no area inaccessible by rail. However, if you look at the American train network, there are a lot of linear lines. Much of the American land isn't covered by the train network. The limited destination options provided by the American Railway discourage people from using it frequently. That's another reason why the government's reluctant to invest in railways, especially when the demand's so low. However, this wasn't always the case in the past. In the late 1960s, two shiny projects were unveiled by the government, the turbo train and the metro liner. Named after the Latin word for tornado, the turbo train was engineered by the United Aircraft Company, UAC, and used the same turbine technology that lifted planes and helicopters. It traveled at a speed of 170 miles per hour, 270 kilometers per hour, setting a record in North America that remains to this very day. But it did not deliver impressively when it came to regular services. Unable to reach its full speed, the train averaged around 63 miles an hour, 100 kilometers per hour. The second high-speed project was the electric metro liner made up of a stainless steel tube. The metro liner reached 164 miles per hour, 260 kilometers per hour on a trial run and promised a 2.5-hour trip between New York and Washington, D.C. Sadly, the metro liner proved to be a lemon. Its various technical issues, like the rattling of air compressor coils, wobbly carriages, etc., doomed the project. Finally, in 2000, a silvery blue electric train named Acela entered the picture. Even though the public was excited to use this new train, Acela didn't live up to the expectations. But much of it wasn't its fault. Much like its predecessors, it had the same problem. There were no dedicated tracks for Acela, and it had to share the tracks with the other freight trains. Throughout history, American governments have tried to reduce the cost of high-speed rails by not constructing exclusive tracks for passenger trains. Acela had to be able to sustain high-force collisions that could not happen on systems dedicated exclusively to passenger trains elsewhere in the world. Critics also claimed that Acela would skip stops to make up for its delay. But not to worry, because there's finally a ray of hope for the American public. A new inner-city railway called the Brightline was unveiled recently. It's the only privately owned and operated inner-city passenger railroad in the United States. Before we go further, what are the criteria for a high-speed train? The most common international definitions specify speeds above 155 miles an hour, 250 kilometers per hour on newly built lines, and speeds above 124 miles per hour, 200 kilometers an hour on upgraded lines as high speed. Brightline has a top speed of 125 miles per hour, 200 kilometers per hour, while the project is marketing itself as a high-speed railway. It's closer to the definition of a higher speed rail. It'll connect Miami and Orlando with possible extensions up to Tampa. There's a lot of traffic between these two locations with an expected 35 million annual travelers. Currently, those who wish to travel from Miami to Orlando have two options: hop on a plane or take the I-95 highway. The I-95 highway is one of the deadliest highways in the world. It routinely claims the lives of hundreds of motorists each year with a death rate of 15 fatalities per 100 miles. As of 2019, the I-95 had a nation-leading 284 deaths, not to mention that it is jam-packed with cars leading to several bottlenecks in the path. So what better way to cash in on an opportunity like this? Brightline's main Orlando station is part of Orlando International Airport's Terminal C. It offers the most direct connection from an intercity rail line to an airport terminal in the United States. This was made possible because Orlando Airport included the railroad station and track access in its master plan, in concert with a state high-speed rail plan. Brightline was able to take advantage of a state policy setting aside right-of-way alongside some highways for high-speed rail. This means that some of its tracks will be shared by freight trains, while some sections will be exclusive for Brightline. The distance between Miami and Orlando by car takes 3 to 5 hours to cover. However, Brightline is offering this distance to be covered in under 3 hours. The train is equipped with comfortable seats, Wi-Fi, charging ports, and refreshments for a comfortable experience. Ever since Brightline was started, more than 10,000 jobs have been created, and the train itself has a positive $6 billion impact on Florida. But it seems like Brightline isn't stopping anytime soon. A new project called Brightline West will connect Las Vegas and Southern California. It'll have additional stations in Apple Valley, Hesperia, and Rancho Cucamonga. Trains will take passengers from Las Vegas to Rancho Cucamonga in just 2 hours and 10 minutes, twice as fast as the normal drive time. Rancho Cucamonga Station will connect to Southern California's regional Metrolink service, allowing for seamless connectivity to downtown Los Angeles and beyond. With the initiation of the first private intercity rail, it's hoped that many others would follow this example. It's rare to see a private company in the railway world, but as you can see with failed governmental projects like the California High-Speed Railway, this is a green signal for America. For those who are unaware, the California High-Speed Railway was promised to the public 15 years ago and is still pretty much limited to just paper. Multiple disasters like delays in buying land and building the line, inaccurate cost estimates, and a lack of funding have drowned the project. Hence, Brightline seems to be a good model for other future railway projects. China could soon have a train that's as fast as a plane. The China Aerospace Science and Industry Corporation, CASIC, has announced that its new magnetically levitated Maglev train reached over 387 miles per hour during testing. This is the fastest speed ever achieved by a superconducting Maglev train. But does it work? Stay tuned. China's Maglev Hyperloop train has shattered the world speed record, reaching an incredible 387 miles an hour in a test run. The engineers behind this project aim to build a train that is over 3 times as fast, breaking the sound barrier and outpacing airplanes. Dubbed the T-Flight, the Maglev train was developed by the state-owned China Aerospace Science and Industry Corporation, CASIC, as reported by New Atlas. Hyperloop trains operate by pushing magnetically levitated pods through tunnels with minimal air resistance, allowing for extremely high speeds. Previously, the record for the fastest Maglev train was held by Japan's L0 series SC Maglev, which can achieve a top speed of 375 miles per hour, according to JR Pass. China's achievement marks a significant leap forward in high-speed rail technology, setting a new standard for the future of transportation. CASIC built a 1.2-mile track in a low-pressure vacuum tube to test the new train. To reach such high speeds, the train needs to face almost no friction. CASIC made sure the test track was incredibly smooth, with a flatness tolerance of just 0.01 inches. This means the difference between the highest and lowest points of the track is only 0.01 inches. The tunnel, which is 20 feet wide, has a geometric size error of less than 0.1 inches, ensuring it's almost perfectly shaped. The entire pipeline can return to normal pressure in 5 minutes. At its theoretical top speed, the Maglev train would outpass even a passenger jet, which typically cruises between 575 and 600 miles an hour, according to Simple Flying. CASIC's ambitions don't end there. They plan to create a connection between Wuhan and Beijing that can reach speeds of up to 1,243 miles an hour based on a video from 2018. The concept of Hyperloop systems involves moving vehicles or pods at speeds much faster than conventional trains, which are limited to about 59 miles an hour in the US. Unlike traditional trains, Hyperloop trains operate in low-pressure tubes, significantly reducing air resistance and allowing for much higher speeds. Elon Musk first proposed the idea of a Hyperloop system for the US in 2013. His vision was aimed to revolutionize transportation with pods traveling at unprecedented speeds. However, more than a decade later, this vision has yet to materialize. One of the major players in the industry, Virgin Hyperloop, ceased operations in 2023. In the T-Flight's second phase of testing, CASIC plans to extend the track to 37 miles and aim for the train to reach 621 miles an hour. This ambitious project could redefine the future of transportation, offering a faster and more efficient alternative to air travel. Surprisingly, this isn't a new idea. Maglev trains trace their roots to technology pioneered at the Brookhaven National Laboratory. In the late 1960s, James Powell and Gordon Danby from Brookhaven received the first patent for a magnetically levitated train design. Powell came up with the idea while stuck in a traffic jam, thinking there had to be a better way to travel on land than cars or traditional trains. He envisioned using superconducting magnets to levitate a train car. These magnets are cooled to extreme temperatures during use, dramatically increasing the power of the magnetic field. The first commercially operated high-speed superconducting maglev train debuted in Shanghai in 2004, with others now operating in Japan and South Korea. In the United States, several routes are being explored to connect cities like Baltimore and Washington, D.C. In maglev technology, superconducting magnets suspend a train car above a U-shaped concrete guideway. Similar to ordinary magnets, these magnets repel each other when matching poles face each other, allowing the train to float above the track and move with minimal friction. In the late 1940s, British electrical engineer Eric Laithwaite, a professor at Imperial College London, developed the first full-size working model of the linear induction motor. He became a professor of heavy electrical engineering at Imperial College in 1964, continuing his work on the linear motor. Linear motors, which don't require physical contact between the vehicle and guideway, became popular in advanced transportation systems during the 1960s and 70s. Laithwaite joined the tracked hovercraft RTV-31 project near Cambridge in the United Kingdom, though it was cancelled in 1973. Laithwaite's linear motor was well suited for the maglev systems. In the early 1970s, he discovered a new magnet arrangement, the magnetic river, which allowed a single linear motor to produce both lift and forward thrust, enabling a maglev system with a single set of magnets. Working with the British Rail Research Division in Derby and several civil engineering firms, this transverse flux system was developed into a functioning model. The first commercial maglev people mover, simply called Maglev, opened in 1984 near Birmingham, England. It operated on an elevated 600-meter monorail track between Birmingham Airport and Birmingham International Railway Station, running at speeds of up to 42 kilometers an hour or 26 miles an hour. The system closed in 1995 due to reliability issues. High-speed transportation patents have been granted to various inventors worldwide. The first relevant patent, U.S. Patent 714,851, issued to Albert C. Albertson in 1902, used magnetic levitation to reduce the weight on the wheels while using conventional propulsion. Early U.S. patents for linear motor propelled trains were awarded to German inventor Alfred Zedden in 1905 and 1907. Cleveland Mayor Tom L. Johnson filed a patent in 1908 for a wheelless high-speed railway levitated by an induced magnetic field, jokingly known as grease lightning. German patents for magnetic levitation trains propelled by linear motors were awarded to Hermann Kemper between 1937 and 1941. An early maglev train was described in U.S. Patent 3,158,765 by G.R. Palgreen in 1959. The first use of maglev in a U.S. patent was by Canadian Patents and Development Limited. Compared to conventional railways, maglev trains can achieve higher speeds, better acceleration and deceleration, lower maintenance costs, improved gradient handling, and lower noise. However, they are more expensive to build, can't use existing infrastructure, and consume more energy at high speeds. From 2002 till 2021, the Shanghai maglev train held the record for the highest operational speed of a passenger train at 431 kilometers an hour. This train uses German Transrapid technology and connects Shanghai Pudong International Airport with the outskirts of central Pudong, covering 30.5 kilometers in just over 8 minutes. Maglev systems achieve levitation in two main ways: electromagnetic suspension (EMS) and electrodynamic suspension (EDS). Propulsion is typically provided by a linear motor. The power needed for levitation is a small percentage of the total energy consumption of a high-speed maglev system. Most energy is used to overcome drag. Vac train technology has been proposed to address the issue. Despite over a century of research and development, there are only 6 operational maglev trains today, 3 in China, 2 in South Korea, and 1 in Japan. In the public imagination, maglev often evokes the concept of an elevated monorail track with a linear motor. Maglev systems may be monorail or dual rail. The SC Maglev MLX-01, for instance, uses a trench-like track, and not all monorail systems are maglevs. Some railway transport systems incorporate linear motors but use electromagnetism only for propulsion, without levitating the vehicle. Such trains have wheels and are not maglevs. The two main types of maglev technology are electromagnetic suspension (EMS) and electrodynamic suspension (EDS). In electromagnetic suspension (EMS) systems, electronically controlled electromagnets in the train attract it to a magnetically conductive, usually steel track. The train levitates by attraction to a ferromagnetic rail, while electromagnets attached to the train are oriented toward the rail from below. The major advantage of suspended maglev systems is that they work at all speeds, unlike electrodynamic systems, which only work at a minimum speed of around 30 km an hour, 19 miles an hour. This eliminates the need for a separate low-speed suspension system and can simplify track layout. On the downside, the dynamic instability demands fine track tolerances, which can offset this advantage. In electrodynamic suspension (EDS) systems, both the guideway and the train exert a magnetic field, and the train is levitated by the repulsive and attractive force between these magnetic fields. In some configurations, the train can be levitated only by repulsive force. In the early stages of maglev development at the Miyazaki test track, a purely repulsive system was used instead of the later repulsive and attractive EDS system. A major advantage of EDS maglev systems is that they're dynamically stable. Changes in distance between the track and the magnets create strong forces to return the system to its original position. In addition, the attractive force varies in the opposite manner, providing the same adjustment effects. No active feedback control is needed. However, at slow speeds, the current induced in these coils and the resultant magnetic flux is not large enough to levitate the train. For this reason, the train must have wheels or some other form of landing gear to support the train until it reaches takeoff speed. Since a train may stop at any location due to equipment problems, for instance, the entire track must be able to support both low and high-speed operation. Another downside is that the EDS system naturally creates a field in the track in front and to the rear of the lift magnets, which acts against the magnets and creates magnetic drag. This is generally only concerned at low speeds and is one of the reasons why JR abandoned a purely repulsive system and adopted the sidewall levitation system. At higher speeds, other modes of drag dominate. The drag force can be used by the electrodynamic system's advantage. However, as it creates a varying force in the rails that can be used as a reactionary system to drive the train without the need for a separate reaction plate, as in most linear motor systems. Lathwaite led the development of such transverse flux systems at his Imperial College laboratory. Alternatively, propulsion coils on the guideway are used to exert a force on the magnets in the train and make the train move forward. The propulsion coils that exert a force on the train are effectively a linear motor. An alternating current through the coils generates a continuously varying magnetic field that moves forward along the track. The frequency of the alternating current is synchronized to match the speed of the train. The offset between the field exerted by the magnets on the train and the applied field creates a force moving the train forward. We're committed to releasing 2 videos a week. Like, share, subscribe, and hit the bell icon for more visionary builds.